Great Barrier Reef is a global treasure. It is the world's largest living structure. It stretches over 2,300 kilometers along Australia's northeast coast. This magnificent reef system is home to a dazzling array of marine life. Thousands of species of fish, corals, and other creatures depend on the reef for their survival. The Great Barrier Reef is also an important economic asset for Australia. It attracts millions of tourists each year, generating
billions of dollars in revenue. However, this natural wonder is facing an unprecedented crisis. Climate change, pollution, and other human activities are taking a heavy toll on the reef's health. Scientists have been warning for years that the Great Barrier Reef is in danger. Their warnings have become increasingly urgent in recent times. The latest research paints a grim picture of the reef's future. The Australian Institute of Marine Science, or AIMS, has been monitoring the health of the Great Barrier Reef for almost 40 years. Their latest findings are alarming, to say the least. The AIMS survey shows that the reef has suffered its most extensive coral die-off on record. This is a major blow to the reef's ability to recover from previous bleaching events. The future of the Great Barrier Reef is uncertain. However, one thing is clear: we need to act now to save this global treasure. The AIMS survey was conducted in 2023. It covered 12 key reef sites. The results of the survey are shocking. Some areas have lost up to 72% of their coral cover. This is the highest coral mortality rate ever recorded on the Great Barrier Reef. The northern and central sections of the reef were hit particularly hard. These areas experienced severe coral bleaching in 2022. This was the fourth mass bleaching event in just 7 years. The bleaching was caused by unusually warm water temperatures. The corals were unable to cope with the stress of the heat and expelled the algae that live in their tissues and provide them with food. The loss of coral cover has a devastating impact on the entire reef ecosystem. Corals are the foundation species of the reef. They provide food and shelter for a wide variety of marine life. When corals die, the entire ecosystem suffers. Fish populations decline and other marine animals lose their habitat. Coral bleaching is a serious threat to coral reefs around the world. It occurs when corals are stressed by changes in their environment. The most common cause of coral bleaching is rising water temperatures. Other stressors include pollution, overfishing, and ocean acidification. When corals are stressed, they expel the symbiotic algae that live in their tissues. These algae, known as zooxanthellae, provide the corals with their vibrant colors and are essential for their survival. Without zooxanthellae, the corals turn white and become more susceptible to disease. If the stress is relieved, corals can recover from bleaching. However, if the stress continues, the corals will eventually die. Mass coral bleaching events are becoming more frequent and severe due to climate change. This is a major concern for the future of coral reefs around the world. Section 4. Climate change, the driving force. Climate change is the biggest threat to the Great Barrier Reef. The burning of fossil fuels is releasing greenhouse gases into the atmosphere. These gases are trapping heat and causing the planet to warm. The oceans are absorbing most of this excess heat. As the oceans warm, the water becomes more acidic. This is because the ocean absorbs carbon dioxide from the atmosphere. When carbon dioxide dissolves in water, it forms carbonic acid. This acidification makes it difficult for corals to build their skeletons. Climate change is also causing more extreme weather events, such as cyclones and floods. These events can damage coral reefs and make it harder for them to recover from bleaching events. The Australian government has been criticized for its inaction on climate change. Australia is one of the world's largest per capita emitters of greenhouse gases. However, the government has been slow to transition to renewable energy sources. In recent years, there has been some progress on climate action in Australia. The government has committed to achieving net zero emissions by 2050. However, many experts believe that this is not enough. They argue that more needs to be done to reduce emissions in the short term. Section 5. The future of the reef. The future of the Great Barrier. Reef is uncertain. However, there is still hope. If we act now, we can reduce the threats to the reef and give it a fighting chance of survival. There are a number of things that can be done to save the Great Barrier Reef. We need to reduce our emissions of greenhouse gases. We need to improve water quality, and we need to manage fishing and tourism sustainably. The Australian government has a key role to play in protecting the Great Barrier Reef. However, a symbol of the beauty and diversity of our planet. We must do everything we can to save it for future generations. Our planet Earth is a dynamic and ever-changing place. One of its most fascinating mysteries is the movement of the magnetic North Pole. This pole, unlike the geographic North Pole, is not fixed. It's on the move, and currently it's headed towards Russia. This movement has captured the attention of scientists and navigators alike. It raises intriguing questions about our planet's inner workings and the impact on our technological systems. Imagine a compass needle, diligently pointing north. Now picture this needle slowly shifting its direction over time. That's essentially what's happening with the magnetic North Pole. This phenomenon is a reminder that our planet is not static. Deep within its core, forces are at play that directly affect our planet's magnetic field and consequently, the location of the magnetic North Pole. This movement isn't just a scientific curiosity, it has real-world implications. Navigation systems, reliant on accurate magnetic readings, need to account for this shift to function correctly. Imagine a ship at sea relying on a compass to guide its way. If the compass isn't calibrated to the shifting magnetic north, the ship could end up miles off course. The movement of the magnetic North Pole serves as a constant reminder of the dynamic nature of our planet. It beckons us to delve deeper into the Earth's core, to understand the forces that drive these magnetic shifts. In the sections that follow, we'll embark on a journey to explore the science behind this wandering pole. We'll unravel the mysteries of Earth's magnetic field, its historical movements, and the potential consequences for our technological world. Before we delve into the magnetic North Pole's movement, it's crucial to understand what it is and how it differs from the geographic North Pole. The geographic North Pole is a fixed point on Earth's surface. It's where all lines of longitude converge. The magnetic North Pole, however, is where Earth's magnetic field lines point downwards. This point is constantly moving due to Earth's dynamic magnetic field. Understanding this distinction is crucial to grasping Earth's magnetism. The magnetic North Pole's journey over time is a testament to the dynamic nature of Earth's magnetic field. It's not a recent phenomenon. This pole has been on the move for centuries, leaving its mark on navigational charts and scientific records alike. Tracing its historical path provides valuable insights into the forces that drive its movement. Early explorers and navigators relied on magnetic compasses to guide their voyages across vast oceans. They were among the first to notice that the direction of magnetic north wasn't quite where they expected it to be based on the geographic North Pole. These discrepancies recorded over time provided the first clues that the magnetic North Pole was not stationary but rather a wanderer. In 1831, James Clark Ross, a British Royal Navy officer and explorer, pinpointed the location of the magnetic North Pole for the first time. He achieved this feat during his Arctic expeditions, braving harsh conditions and treacherous ice to make this groundbreaking discovery. His findings confirmed what many had suspected. The magnetic North Pole was indeed a moving target. Since Ross's discovery, scientists have been diligently tracking the pole's movements. In the early 20th century, the magnetic North Pole was located in Canada. However, in a surprising turn of events, it began to accelerate towards Siberia, Russia. This acceleration, reaching up to 55 kilometers per year at times, has captivated the attention of the scientific community. Section 4. The Earth's Core, a dynamo in motion. To comprehend the magnetic North Pole's movements, we must journey deep into the Earth's core. This churning molten realm drives our planet's magnetic field. Imagine a sphere of solid iron about the size of the moon. Surrounding this is the outer core, a layer of liquid iron and nickel. This molten metal churns and flows, driven by Earth's rotation. This motion powers Earth's magnetic field. The liquid metal generates electric currents, creating a self-sustaining dynamo. These currents drive the movement of the magnetic North Pole. Hold on to your seats. Gravity's about to blow your mind. Gravity might be the weakest of the four fundamental forces of nature, but don't let that fool you. It's got a reach that stretches across the cosmos. Gravity is the invisible hand that sculpts galaxies, directs the dance of stars, and holds entire planets in its grip. While electromagnetism and nuclear forces dominate at the atomic level, gravity reigns supreme on the cosmic stage. Imagine this. Without gravity, our universe would be a chaotic mess, with no stars, no planets, and no life as we know it. Every time you jump, gravity pulls you back down. But on a grander scale, it's the glue that binds the universe together. So next time you look up at the night sky, remember, gravity's got your back. Thanks for watching. Don't forget to like, subscribe, and hit that bell for more cosmic wonders.
भैया
हाँ
लखनऊ की बस है ना?
हाँ भैया
कितने का है? 800?
950 का है।
और भैया 950 का।
Our planet keeps a meticulous diary of its history. This diary is written in the language of rocks, layers upon layers of them, each telling a story of a bygone era. But what happens when a page goes missing from this grand chronicle? Scientists at Stanford University stumbled upon a perplexing gap in Earth's rock record, a 34-million-year void spanning a period known as the Eocene-Oligocene transition. This discovery, like any good mystery, has sent geologists scrambling for answers. This missing chapter coincides with a pivotal period in Earth's history. The Eocene-Oligocene transition, approximately 34 million years ago, marked a time of dramatic climate change. Temperatures plummeted, ice sheets grew, and the planet underwent a major reorganization of its ecosystems. Understanding this transition is crucial for comprehending Earth's climate system and its potential for future change. The Stanford study, published in the journal Geology, focuses on a geological formation in Italy. This formation, known as the Contessa section, is renowned among geologists for its remarkably complete record of the Eocene-Oligocene transition, or so they thought. The Eocene epoch, which began about 56 million years ago, was a time of incredible warmth. Palm trees swayed in what is now Alaska, and crocodiles roamed the Arctic. But this balmy era was not destined to last. As the Eocene gave way to the Oligocene epoch, Earth's climate underwent a dramatic transformation. The transition was triggered by a complex interplay of factors, including volcanic activity, changes in Earth's orbit, and a decrease in atmospheric carbon dioxide levels. The result was a significant drop in global temperatures, leading to the formation of the Antarctic ice sheet and a cooling of the planet's oceans. This period of rapid climate change had a profound impact on life on Earth. Many species unable to adapt to the cooler conditions went extinct. Others migrated to lower latitudes or evolved new characteristics that allowed them to survive in a changing world. The Eocene-Oligocene transition serves as a stark reminder of the Earth's capacity for dramatic climate shifts. By studying this ancient event, scientists hope to gain a better understanding of how our planet's climate system works and how it might respond to future changes. Imagine Earth's history as a giant book. Each layer of rock represents a page in this book, with the oldest layers at the bottom and the youngest at the top. These layers, known as sedimentary rocks, are formed over millions of years as sediments like sand, mud, and the remains of organisms accumulate and harden. Just like the pages of a book, sedimentary rocks preserve clues about the past. By studying the types of sediments present, the fossils they contain, and the chemical composition of the rocks, geologists can piece together a picture of what Earth was like millions of years ago. For example, the presence of fossilized coral reefs indicates a warm, shallow marine environment. Layers of coal tell us that swamps and forests once flourished in a particular region. And the chemical signature of the rocks can reveal information about past climates, ocean currents, and even volcanic eruptions. Sedimentary rocks are essential for understanding Earth's history. They provide a tangible record of past environments, life forms, and geological events, allowing us to trace the evolution of our planet over billions of years. The Stanford researchers, led by geologist Jeremy Caves Rugenstein, were expecting to find a continuous record of sedimentation spanning the Eocene-Oligocene transition at the Contessa section. After all, this site was chosen for its reputation as a complete archive of this crucial period. However, what they discovered instead left them baffled. Using a technique called magnetostratigraphy, which analyzes the magnetic properties of rocks, the team meticulously dated the sediment layers. To their astonishment,
They found a significant gap in the rock record. Approximately 34 million years worth of sediment was simply missing. It was as if several pages had been ripped out of Earth's history book. This unexpected finding sent shockwaves through the geological community. How could such a substantial chunk of time be unaccounted for in a location known for its complete geological record? The missing layers presented a perplexing puzzle, challenging our understanding of sedimentation patterns in Earth's history during this critical period. The Great Ocean Conveyor Belt, a possible explanation. The missing sediment layers sent scientists on a quest for explanations. One theory points to the ocean's circulation system, the Great Ocean Conveyor Belt. This system transports warm waters from the tropics towards the poles and colder waters from the poles towards the equator. It regulates Earth's climate by distributing heat globally. During the Eocene-Oligocene transition, a shift in ocean currents may have occurred. Changes in temperature or salinity could have altered sedimentation patterns, leading to the observed gap in the rock record.
मेरा नाम पूजा गोयल है। मैंने टोटलमेंट ज्वाइन किया 2019 अगस्त में। मैंने नेट पे सर्च किया ऐसी कोई कंपनी मिल जाए कि जो सभी कंपनियों को अप्रोच कर सके और कोटेशन भी अच्छा और तुरंत फास्ट कस्टमर को सर्विस भी मिल सके। तो मुझे टोटलमेंट का नाम मिला। मैंने उनको कांटेक्ट किया और जितनी भी मैंने लिस्ट निकाली थी उसमें टोटलमेंट ने मुझे फास्ट कांटेक्ट किया। 2-3 दिन में उन्होंने प्रोसेस भी ज्वाइनिंग का बता दिया और मुझे पहली बात तो ये इंश्योरेंस का कोई आइडिया नहीं था, तो टोटलमेंट से ज्वाइन करने के बाद और ज़्यादा आइडिया आ गया। कस्टमर हमेशा ऐसा बोलते थे कि आप एक ही कंपनी का देते हो, ये कंपनी ये देती है, ये कंपनी वो देती है। तो पहली बात तो ये थी कि मुझे अलग अलग कंपनी का कोटेशन मिल रहा है। दूसरी बात ये थी कि
Section 6, Starvation in the Deep, a new theory emerges. While the ocean current theory offers a plausible explanation, Stanford scientists propose a different hypothesis. They suggest the missing sediment layers result from deep-sea starvation. During the Eocene-Oligocene transition, as ice sheets expanded, nutrient delivery to the deep ocean reduced. This created a starvation effect, leading to a decline in marine life. Fewer organisms contributed to sediment formation. This theory highlights Earth's interconnected systems and climate change's impact. Section 7. Challenging existing models, a paradigm shift. The discovery of the missing sediment layers and the subsequent scramble for explanations have sent ripples through the field of geology. It challenges our existing models of sedimentation, particularly during periods of significant climate change. Traditionally, geologists have assumed that sedimentation rates remain relatively constant over long periods, barring major catastrophic events. The Contessa section finding, however, suggests that this assumption may not always hold true, especially during times of rapid environmental change. This discovery underscores the need for a more nuanced understanding of how sedimentary records are formed and how they reflect Earth's history. It highlights the importance of considering factors such as ocean currents, nutrient cycles, and biological productivity when interpreting geological data. The missing layers serve as a reminder that Earth's history is not always neatly preserved in the rock record. There are gaps, inconsistencies, and surprises waiting to be uncovered, each challenging our assumptions and pushing the boundaries of scientific understanding. Section 8, Echoes of the Past, Lessons for the Present. The Eocene-Oligocene transition, with its dramatic climate shift and its impact on life on Earth, holds valuable lessons for us today. As our planet grapples with the consequences of human-induced climate change, understanding past climate transitions becomes increasingly crucial. The rapid temperature drop during the Eocene-Oligocene transition, while triggered by natural processes, serves as a stark reminder of Earth's climate sensitivity. It highlights the potential for significant and rapid climate change, even in the absence of human interference. Moreover, the extinction of numerous species during this period underscores the vulnerability of ecosystems to rapid environmental change. It serves as a cautionary tale, reminding us that our actions today have the potential to trigger profound and irreversible changes in the natural world. By studying past climate transitions, such as the Eocene-Oligocene event, scientists can gain insights into the potential consequences of our current trajectory. These insights can inform our efforts to mitigate climate change, adapt to its impacts, and preserve the planet's biodiversity for future generations. Section 9. The urgency of climate action. The discovery of the missing sediment layers and the insights it provides into Earth's past climate reinforce the urgency of addressing our current climate crisis. The parallels between the Eocene-Oligocene transition and the changes we are witnessing today are too striking to ignore. Like the Eocene-Oligocene transition, we are experiencing a rapid increase in global temperatures, primarily driven by the burning of fossil fuels and deforestation. These activities release greenhouse gases into the atmosphere, trapping heat and altering Earth's climate system. The consequences of inaction are dire. We are already witnessing rising sea levels, more frequent and intense heat waves, changes in precipitation patterns, and an increase in extreme weather events. These impacts will only intensify if we fail to curb our emissions and transition to a more sustainable future. The lessons from the Eocene-Oligocene transition are clear. Earth's climate is capable of rapid and dramatic change, and these changes can have profound and lasting impacts on life on Earth. We have a responsibility to act now to mitigate climate change and protect our planet for future generations. Section 10. Unraveling Earth's Mysteries. The quest continues. The discovery of the missing sediment layers at the Contessa section is just one example of Earth's mysteries. As scientists probe our planet's depths, they uncover new insights into its history and evolution. Each discovery, whether it's a missing layer of sediment, a fossilized creature, or a new understanding of Earth's processes, deepens our appreciation for our planet. The quest to understand Earth is an ongoing journey driven by curiosity and a desire to unravel its mysteries. Section 11. Our place in time. A deeper understanding. As we delve deeper into Earth's history, we gain a profound appreciation for our place in time. We are but one species among countless others that have inhabited this planet over billions of years. The Eocene-Oligocene transition reminds us of the impermanence of any single species or ecosystem. It highlights the interconnectedness of all life on Earth. By studying Earth's past, we understand the forces shaping our present and future. We appreciate the delicate balance of Earth's systems. The quest to understand Earth's history is a journey of self-discovery. It connects us to our planet's past and inspires us to become better stewards of our future. On October 2nd, 2024, the skies will come alive with a celestial spectacle, a ring of fire solar eclipse. This event promises to be one of the most awe-inspiring astronomical phenomena of the decade, drawing enthusiasts and casual observers alike to witness its beauty. This astronomical event, known scientifically as an annular solar eclipse, occurs when the moon passes between the sun and Earth. During this alignment, the moon is positioned in such a way that it covers the center of the sun, leaving the outer edges visible. However, unlike a total solar eclipse, the moon during a ring of fire eclipse doesn't completely obscure the sun. Instead, it leaves a thin, glowing ring of sunlight visible around its edges. Instead, a brilliant ring of sunlight, often described as a ring of fire, blazes around the moon's silhouette, creating a breathtaking sight that has captivated skywatchers for centuries. This phenomenon is not only visually stunning, but also a reminder of the intricate dance of celestial bodies. This celestial ballet is a relatively rare occurrence. Such events are eagerly anticipated by astronomers and skywatchers, who often travel great distances to experience the spectacle firsthand. The alignment of the sun, moon, and Earth must be precise for this event to unfold. The exact positioning is crucial, as even a slight deviation can result in a different type of eclipse or no eclipse at all. The moon's orbit around Earth is not perfectly circular, but slightly elliptical. This means that the distance between the Earth and the moon varies over time. When an eclipse occurs and the moon is at or near its farthest point from Earth or apogee in its orbit, it appears slightly smaller in the sky. This smaller size is what allows the outer edges of the sun to remain visible. This smaller apparent size prevents the moon from fully covering the sun's disk, resulting in the mesmerizing ring of fire effect. This unique visual phenomenon is a testament to the wonders of our universe and the precise mechanics that govern celestial events. A ring of fire eclipse is a testament to the awe-inspiring scale and precision of our solar system. The fact that these celestial bodies, separated by vast distances, align in such a way as to create this spectacle is a testament to the laws of physics that govern their movements. It's a reminder that we are part of something much larger than ourselves, a cosmic dance that has been playing out for billions of years. Eclipses have fascinated humankind since the dawn of civilization. Ancient cultures often attributed spiritual or mythological significance to these celestial events. They were seen as omens, portents of change, or messages from the gods. Today, while we understand the scientific principles behind eclipses, they haven't lost their ability to inspire wonder and a sense of connection to the cosmos. The October 2nd, 2024 Ring of Fire eclipse will be visible across North and South America. Skywatchers in a narrow band stretching from the northwestern United States to Central America and northern South America will have the opportunity to witness the annular phase of the eclipse, where the Ring of Fire effect will be most prominent. Outside of this path, a partial solar eclipse will be visible across a much wider region. For those fortunate enough to be located within the path of annularity, the eclipse promises to be an unforgettable experience. As the moon slowly glides in front of the sun, the sky will gradually darken. The temperature may drop noticeably. And then, as the moon reaches its point of greatest coverage, the dazzling ring of fire will emerge, casting an ethereal glow upon the landscape. The path of annularity, where the ring of fire will be visible, will track across a swath of the Americas. It will make landfall in Oregon, crossing into Nevada, Utah, and New Mexico before entering Texas. From there, the path continues over Mexico's Yucatan Peninsula, Belize, and portions of Honduras, Nicaragua, Panama, Colombia, and Brazil. Along this path, the duration of the annular phase during which the ring of fire is visible will vary depending on location. The maximum duration of annularity, exceeding 5 minutes in some areas, will occur near the center line of the path. Those situated closer to the edges of the path will experience a shorter duration of the annular phase. Section 5. A glimpse of the eclipse, partial phases beyond the path. While the full spectacle of the Ring of Fire will be confined to the path of annularity, millions more will have the opportunity to witness a partial solar eclipse. This includes a vast region encompassing most of North America, Central America, and Northern South America. During a partial solar eclipse, the moon appears to take a bite out of the sun's disk. The extent of this bite will depend on the observer's location. Those closer to the path of annularity will see a greater portion of the sun obscured, while those farther away will witness a more subtle effect. Section 6. Duration of the eclipse. A fleeting moment in time. The entire duration of the eclipse, from the moment the moon first begins to cover the sun until it moves completely off the solar disk, will last for several hours. However, the annular phase, during which the Ring of Fire is visible, will be much shorter, typically lasting only a few minutes. The exact times for the beginning, peak, and end of the eclipse will vary depending on location. It's essential to consult local resources such as astronomical societies or online eclipse calculators to obtain precise timings for your specific area. Section 7. Prime viewing locations, seeking out the best celestial views. Selecting an optimal viewing location can enhance your eclipse experience. Ideally, choose a spot with an unobstructed view of the horizon, free from tall buildings or trees that could block your view of the sun. Consider factors such as weather conditions. Clear skies are essential for optimal viewing. Check local weather forecasts closer to the eclipse date and have a backup plan in case of cloud cover. Additionally, minimize light pollution by selecting a viewing location away from city lights. National parks, open fields, or elevated areas often provide excellent vantage points. Section 8. Protecting your eyes. Safe viewing practices for the eclipse. Observing the sun directly, even during an eclipse, can cause serious eye damage. It's crucial to protect your eyes at all times during all phases of the eclipse. Never look directly at the sun without proper eye protection. To safely view the eclipse, use certified solar eclipse glasses or viewers that meet international safety standards, ISO 12312-2. These glasses are specifically designed to filter out the sun's harmful ultraviolet and infrared radiation. Ordinary sunglasses, even very dark ones, are not sufficient to protect your eyes during an eclipse. Section 9. Alternative viewing methods. Witnessing the eclipse indirectly. If you don't have access to certified solar eclipse glasses, there are alternative methods for safely observing the eclipse. It's crucial to never look directly at the sun without proper protection, as it can cause serious eye damage. One option is to create a pinhole projector, which allows you to indirectly view the sun's image. This simple device can be made with materials you likely already have at home. To make a pinhole projector, simply poke a small hole in a piece of cardboard or paper. The hole should be small and round for the best results. Hold the cardboard up to the sun and project the sunlight onto a white surface, such as a piece of paper or the ground. The image of the sun will be projected through the pinhole. You'll be able to see the shape of the sun and observe the eclipse as the moon passes in front of it. This method is safe and effective for viewing the eclipse without risking your eyesight. Another safe viewing method is to use a mirror to project the sun's image onto a wall or screen. This technique can be particularly useful if you want to share the experience with a group of people. Cover a small mirror with a piece of paper or cardboard with a small hole in the center. This will help focus the sunlight into a clear image. Angle the mirror so that it reflects the sunlight onto a surface. Adjust the angle until you get a clear and sharp image of the sun. This method allows you to safely enjoy the eclipse without direct exposure to the sun's rays. Section 10. The science behind the spectacle. Understanding the mechanics of an annular eclipse. An annular solar eclipse is a celestial phenomenon that results from a delicate interplay of cosmic geometry and orbital mechanics. The moon's orbit around Earth is not perfectly circular, but slightly elliptical, meaning its distance from Earth varies throughout its orbit. When an eclipse occurs and the moon is at or near its farthest point from Earth, called apogee, its apparent size in the sky is slightly smaller. This smaller apparent size prevents the moon from fully covering the sun's disk, even when the sun, moon, and Earth are perfectly aligned. As a result, a ring of sunlight remains visible around the moon's silhouette, creating the characteristic ring of fire effect. Section 11. Conclusion. Embracing the wonder of the cosmos. The Ring of Fire. Solar eclipse on October 2nd, 2024 offers a rare opportunity to witness a celestial spectacle that has captivated humanity for centuries. This event, where the moon covers the center of the sun, leaving a glowing ring, is a reminder of the intricate dance of celestial bodies. As we gaze skyward and marvel at this cosmic ballet, we are reminded of the vastness of the universe and our place within it. The night sky, with its countless stars and galaxies, invites us to ponder the mysteries of existence and the wonders that lie beyond our planet. Whether you find yourself within the path of annularity, witnessing the full glory of the Ring of Fire, or observing a partial eclipse from afar, remember to protect your eyes at all times. The beauty of the eclipse should not come at the cost of your vision. Use certified solar eclipse glasses or viewers, which are specifically designed to filter out harmful rays, or employ alternative safe viewing methods, such as pinhole projectors or even welding glass, to ensure a safe and enjoyable experience. Let this celestial event inspire a sense of wonder and curiosity about the cosmos. Share the experience with friends and family, and let it spark conversations about the universe and our place in it. Take the time to appreciate the intricate workings of our solar system and the remarkable phenomena that unfold above us. Each event, each movement, is a testament to the beauty and complexity of the cosmos, inviting us to explore and learn more. India's Pragyan rover has made an exciting discovery. This small but mighty rover has been diligently exploring the lunar surface, and its latest find is truly remarkable. It found a new crater on the moon. This discovery adds to our understanding of the moon's geological history. This crater is very old and very large. Its age and size make it a significant feature on the lunar landscape. It's about 160 kilometers wide. To put that into perspective, that's an area larger than many metropolitan cities on Earth. That's bigger than many cities on Earth. Imagine a city-sized crater on the moon, a testament to the moon's dynamic past. The Pragyan rover is part of India's Chandrayaan-3 mission. This mission aims to explore and study the moon in unprecedented detail. This mission is exploring the moon's South Pole. The South Pole is a region of great interest due to its unique characteristics. This area of the moon is very interesting to scientists. It holds many secrets about the moon's history and composition. It's home to many craters. These craters provide valuable information about the moon's past. Some of these craters are permanently shadowed. These shadowed regions are of particular interest because they may hold resources. Scientists believe these craters might contain water ice. Water ice on the moon could be a game changer for future space exploration. This ice could be very valuable for future lunar missions. It could provide water for astronauts and be used to produce fuel, making long-term lunar habitation possible. This new crater is important for understanding the moon's history. The moon's surface is like a time capsule, preserving the events of the past. It's located near the Aitken Basin, a region of great scientific interest. The Aitken Basin is the largest and oldest impact basin on the moon. It spans over 2,500 kilometers in diameter. When the Aitken Basin formed, it threw out a lot of material, scattering debris across the lunar surface. Some of this material probably landed in the newly discovered crater, providing a unique opportunity for study. By studying the material in the new crater, scientists can learn about the early moon. They can analyze the composition and age of the rocks. They can learn what the moon was made of billions of years ago, offering clues to its origins. This information can help us understand how the moon formed. The processes that shaped it are key to our knowledge. It can also help us understand how the solar system formed. By piecing together these ancient clues, we can unravel the history of our cosmic neighborhood. The new crater is like a time capsule, preserving the history of the moon in its layers. It's been collecting dust and rock for billions of years, each layer telling a story of a different era. This material holds clues about the moon's past, offering a glimpse into the processes that shaped it. By studying this material, scientists can learn about the conditions on the early moon, such as its volcanic activity and the presence of water. They can learn about the impacts that shaped the lunar surface, revealing the moon's violent history. Scientists believe this crater is older than the Aitken Basin, one of the largest known impact basins in the solar system. This means it formed very early in the moon's history, possibly during the period known as the Late Heavy Bombardment. At that time, the solar system was a very different place, with young planets and moons still forming. There were many more asteroids and comets flying around, remnants of the solar system's formation. These objects crashed into the planets and moons, creating craters and shaping their surfaces in dramatic ways. Understanding these ancient impacts helps scientists piece together the history of our solar system and the forces that have shaped it. Future missions to the moon will continue to uncover these secrets, providing new insights into our celestial neighbor. Section 4. The impact of discovery. The discovery of this crater is a big deal for lunar science. It gives us a new window into the moon's past. By studying this crater, we can learn more about how the moon formed and evolved. The Pragyan rover is equipped with special instruments. These instruments allow it to study the crater in detail. The rover can take high-resolution images of the crater. It can also analyze the chemical composition of the crater's surface. Section 5. Future lunar missions. This discovery will help plan future lunar missions. Knowing the location and composition of this crater will allow scientists to target it for further study. They may send new rovers or even astronauts to collect samples. The discovery also highlights the importance of the moon's South Pole. This region is rich in scientific potential. It may hold the key to understanding the early solar system. It may also hold valuable resources for future human exploration. Section 6. Conclusion. The Pragyan rover's discovery is a major milestone in lunar exploration. It reminds us that the moon still holds many secrets. By continuing to explore the moon, we can unlock these secrets and learn more about our place in the universe. This discovery is a testament to the power of human curiosity and ingenuity. It inspires us to keep exploring and pushing the boundaries of knowledge.
The Sun is 875,000 miles across, though scientists usually use kilometers, in which case it is 1,392,000 kilometers across. It is also very heavy. To write its weight in kilograms, 1 coloniers, 2 pounds, more or less. You write 2 followed by 30 zeros. The sun is about 2,000, a kilo, a 2 with 30 zeros, kilos, or about 4.4 with 30 zeros, lbs. Maybe you learned in your physics class what's the difference between weight and mass. For example, a person of 50 kilo weighs 50 kilos on Earth, 8.3 on the moon, and 1,354 on the sun. The radius of the sun is about 700,000 kilometers, 435,000 miles. As you know, the circumference of a circle is 2 pi r, where r is the radius. That makes 4.4 million kilometers, 2.7 million miles for the circumference. For comparison, the circumference of the Earth is about 40,000 kilometers, 25,000 miles, about 100 times smaller than the Sun. The Sun has a mass of 210 kilograms, which is about 300,000 times greater than the mass of the Earth. Mass depends on the amount of matter in an object. Weight, on the other hand, varies with respect to local gravity. However, the sun is not sitting near anyone's gravitational field. More videos, subscribe the channel. Thank you.
Discovered in 1986 by Christian Lascaux, Moville Cave has remained sealed off from the outside world for an estimated 5.5 million years. Sealed beneath the Earth's surface, this unique ecosystem has been thriving in darkness, providing a rare glimpse into the resilience and adaptability of life under extreme conditions. Tucked away in southeastern Romania near Mangalia lies a unique and mysterious cave that has captivated the scientific community. Discovered in 1986 by Christian Lascaux, Moville Cave has remained sealed off from the outside world for an estimated 5.5 million years. Sealed beneath the Earth's surface, this unique ecosystem has been thriving in darkness, providing a rare glimpse into the resilience and adaptability of life under extreme conditions. Moville Cave is an extraordinary subterranean habitat, around 300 meters long and approximately 60 meters deep. The cave's entrance is a narrow, vertical shaft, which has kept it isolated from the outside world. The air inside is toxic, with elevated levels of carbon dioxide, up to 100 times higher than the surface, and hydrogen sulfide, while oxygen levels are significantly lower. Despite these seemingly sterile conditions, a complex ecosystem has flourished in the cave. What sets Moville Cave apart from other subterranean habitats is the complete absence of sunlight, which means that life within the cave has adapted to rely on chemosynthesis instead of photosynthesis. Chemosynthetic bacteria, which form the base of the food chain, derive energy from the chemical reactions caused by the high concentrations of sulfur and other minerals in the cave's waters. These bacteria serve as the primary food source for a variety of invertebrates, including various species of worms, crustaceans, and spiders. Remarkably, over 48 species have been identified within the cave, and more than 30 are found nowhere else on Earth. The uniqueness of this ecosystem has led scientists to describe it as a natural laboratory for studying evolutionary processes and the limits of life in extreme environments. The cave's delicate ecosystem faces numerous challenges, including climate change, human-induced disturbances, and potential contamination from outside sources. Efforts to preserve and protect Moville Cave are crucial, as its inhabitants are highly specialized and may not be able to survive in other environments. Moville Cave is a testament to the resilience and adaptability of life, even in the most extreme and inhospitable environments. The study of this unique ecosystem not only sheds light on the limits of life on Earth, but also offers potential insights into the possibilities of life beyond our planet. As we continue to explore and understand the complexities of this hidden world, Moville Cave stands as a reminder of the astonishing diversity and adaptability of life on our planet.
For such great information, don't forget to like the video and subscribe to the channel. Thank you.
How
many balls were originally there in one test over?
6 now, for sure. I'll go with 8. No, that's not correct. Let's see. Wow, I didn't expect that.
ये गूगली देने वाला सवाल है. गूगल पे ढूंढोगे तो सब जानोगे.
The sun is a big ball of gas and plasma. Most of the gas, 91%, is hydrogen. It is converted into energy in the sun's core. The point moves outward through the interior layers into the sun's atmosphere and is released into the solar system as heat and light. In the sun's core, gravitational forces create tremendous pressure and temperatures. The sun's temperature in this layer is about 27 million degrees Fahrenheit, 15 million degrees Celsius. Hydrogen atoms are compressed and fused, creating helium. This process is called nuclear fusion. As the gases heat up, atoms break apart into charged particles, turning the gas into plasma. The energy, mostly in the form of gamma-ray photons and neutrinos, is carried into the radiative zone. According to Sten Odenwald on NASA's Ask the Space Scientist page, photons can bounce around randomly in this zone, from somewhere between a few thousand and about 1 million years before traveling to the surface. Why don't we know how long it takes for a photon to travel outward from the sun's center? For one thing, scientists can't see into the core to track a photon from its birth. Instead, they must rely on models that follow the infamous drunkard's walk problem. According to this scenario, the distance a drunken person travels while making random left and right turns is their typical step size times the square root of the number of steps taken. For a randomly traveling photon in the solar center, this depends on what is used for the mean free path, or average distance traveled, of radiation. These numbers range from 4,000 to millions of years, though most solar scientists rely on 170,000 years.
For such great information, don't forget to like the video and subscribe to the channel. Thank you.
Antarctica is one of the world's 7 continents. It is the 5th largest, being bigger than the whole of Europe and nearly twice the size of Australia. On average, Antarctica is the windiest of all the continents. Because its landscape is flat over very large distances, winds can reach speeds of up to 320 km/h. On other continents, winds only reach these speeds during storms, cyclones, hurricanes, tornadoes, etc. Antarctica is the driest continent on the planet and is officially classified as a desert. The cold temperatures and strong winds result in very low humidity, which makes it difficult for clouds to form. Along the coastline, especially on the Antarctic Peninsula, rain is possible, but it is still rare. Although it is a desert, Antarctica contains 70% of the Earth's fresh water. However, it is mostly bound up in the enormous ice sheet, so you won't be drinking out of too many running streams there. Home of the South Poles. The current locations of both the geographic South Pole, where the Earth's surface intersects the Earth's axis of rotation, and the magnetic South Pole, where the direction of the Earth's magnetic field is vertically upwards, lie within Antarctica. However, this has not always been the case. Millions of years ago, Antarctica used to be closer to the equator, but has now moved to its position at the bottom of the planet due to tectonic motion. If you are standing at the magnetic South Pole, then everywhere is north of you. The magnetic South Magnetic Pole currently lies almost 3,000 kilometers from the geographic South Pole and moves at the rate of about 5 kilometers a year. Antarctica is positioned asymmetrically around the South Pole. This means that the South Pole is not always located the same distance from the coastline. The most remote place in Antarctica, the one furthest from all coastlines, is called the South Pole of Inaccessibility and lies about 900 kilometers from the geographic South Pole. Antarctica is the largest ice sheet in the world. More than 98% of Antarctica is covered with ice. This makes it the largest ice sheet in the world, with Greenland coming in second. It is estimated that Antarctica contains around 90% of the world's ice, and if it all melted, the original behemoth remained. Home to the southernmost active volcano, Mount Erebus is one of the Earth's few constantly active volcanoes. It continuously releases gas and has had several eruption episodes over the years, resulting in lava flowing down its slopes and ejected molten rock. It is the site of the Earth's only long-lived lava lakes and is Antarctica's second highest mountain. Antarctica has high mountains. Antarctica's highest mountain, Mount Vinson, stands 4,987 meters tall. This is just over half the height of Mount Everest. It is named for Carl Vinson, a U.S. congressman who keenly supported Antarctic expeditions and was submitted for the first time in 1966 by a team led by American Nicholas Clinch. The Gamburtsev Mountains, also referred to as the Ghost Mountains, stretch for 1,200 kilometers across Antarctica and reach heights of more than 3,000 meters. However, you can't see them because the thickness of the ice in those regions is more than 4,000 m. They are completely buried by snow and ice. The Transantarctic Mountains run for more than 3,500 kilometers, making them one of the longest mountain ranges on the planet. They essentially run from the Weddell Sea to the Ross Sea and divide Antarctica into east and west, with East Antarctica making up 2/3 of the continent. Their summits are generally ice-free, and they are the location of most of Antarctica's dry valleys. There are several rift systems in Antarctica, both in the east and the west. The West Antarctic Rift System spans an enormous area. It is 3,000 kilometers long and 700 kilometers wide, and contains the Ferrigno Rift, a 1.6 kilometer deep canyon that is almost as deep as the Grand Canyon. Scientists think that this canyon is causing this part of Antarctica to lose ice more rapidly than expected. Discovered under the Antarctic ice sheet. Geothermal heat from the Earth's interior and insulation from above by the thick layers of ice ensures that they remain liquid. The freshwater Lake Vostok is the largest of these. Buried under about 4 kilometers of ice, it is a subglacial lake, meaning it is encased by the ice of a glacier, not rock or earth. Part of the remote Taylor Glacier in East Antarctica, the disturbing red color of Blood Falls, was a mystery for more than 100 years. Then, in 2017, scientists discovered that the water, which originates from a subglacial lake, is high in salt and oxidized iron. When the water comes into contact with air, the iron rusts, giving it its amazing red color. It has the saltiest lake on Earth. At the base of the Transantarctic Mountains, the Don Juan Pond is the saltiest body of water on Earth. Its salt concentration is 40%, compared with 30% for the Dead Sea and 3.5% for normal seawater. The salt is actually calcium chloride, which lowers the freezing point of water even more than sodium chloride, which is what you use for table salt. This and the high salinity of the lake means it stays liquid even in the frigid temperatures of Antarctica. It is surrounded by a permanent current. The circumpolar current is the world's largest wind-driven current. It circles clockwise around Antarctica from west to east and helps to keep the continent cold by blocking the warmer water from more temperate oceans. It is very rich in nutrients, which is why there is a lot of marine life near Antarctica. It helps that the dark meteorites stand out against the pristine white snow and ice of Antarctica. But the cold, dry atmosphere also helps to preserve them against the usual weathering processes. There are no polar bears in Antarctica. Polar bears are only found in the Arctic, not the Antarctic. While there may not be any polar bears or sled dogs, Antarctica is one of the best places in the world to see penguins. Antarctica. It would be more proper to ask, what is the mass of planet Earth? The quick answer to that is approximately 6 x 1024 kilograms. The interesting sub-question is, how did anyone figure that out? It's not like the planet steps onto the scale each morning before it takes a shower. The measurement of the planet's weight is derived from the gravitational attraction that the Earth has for objects near it. It turns out that any two masses have a gravitational attraction for one another. If you put two bowling balls near each other, they will attract one another gravitationally. The attraction is extremely slight, but if your instruments are sensitive enough, you can measure the gravitational attraction that two bowling balls have on one another. From that measurement, you could determine the mass of the two objects. The same is true for two planets in space. Newton showed that for spherical objects, you could make the simplifying assumption that all of the object's mass is concentrated at the center of the sphere. The following equation expresses the gravitational attraction that two spherical objects have on one another. F, G, M1, M2, R2. For such great information, don't forget to like the video and subscribe to the channel. Thank you.
Whether it's glowing lava snaking into the sea or lightning blooming in billowing ash clouds, the sight of an erupting volcano inspires awe and wonder. Now imagine 1,500 of these suckers all shooting off at once. That's how many active volcanoes dot the Earth, plus an unknown number hidden under the ocean. Every day, between 10 and 20 volcanoes are erupting somewhere on Earth, but scientists say the chance of every volcano on the planet erupting at once is so small that it's impossible. But what if it did happen? Would Earth as we know it survives? Not likely, said Parv Sethi, a geologist at Radford University in Virginia. Even if only the volcanoes on land blasted in sync, the effects would trigger an environmental domino chain many, many times more powerful than a nuclear winter, Sethi said. Things will become so bad that I wouldn't want to survive on an Earth like this, he told Live Science. The two big hazards from worldwide volcanic cataclysm are ash and volcanic gases. While the explosions and outpourings of lava would be deadly to people living close by, the number of deaths would pale compared to those caused by the ensuing climate change. For such great information, don't forget to like the video and subscribe to the channel. Thank you.
जो दिल चाहे, it's on Amazon Prime.
हम दोनों सास बहू को ना कुकिंग का बड़ा शौक है। ये देख लेमन टार्ट Amazon Prime पर सुबह ऑर्डर किया हमने। बेकिंग शीट, ब्रश, टार्ट पैन और ब्लेंडर भी। शाम तक तो आ भी गए। और ये हमारा पहला फ्रेंच लेमन टार्ट तैयार। Extraordinary.
जो दिल चाहे, it's on Amazon Prime. 10 lakh plus products delivered today. Shopping plans start at rupees 399 per year.
The Russian forestry industry is a set of Russian industries related to wood harvesting and processing. As one of the oldest sectors in the country's economy, Russia's timber industry continues to bring in about $20 billion per year. Russia has more than a fifth of the world's forests, making it the largest forest country in the world. According to data for 2015, the total forest area has exceeded 885 million hectares, representing 45% of the total area of the country. The stock of wood in the area was 82 billion cubic meters. A significant proportion of revenue from the industry is generated by the export of raw materials from sawing logs. For a long time, Russia was the main supplier of raw wood materials in Europe. However, according to a 2012 study by the Food and Agriculture Organization of the United Nations and the government of the Russian Federation, the potential of Russian forests is underutilized, and Russia's share of the global trade in forest products is less than 4%. As part of Russia's total industrial production, Russia's timber industry sectors are in 7th place in terms of production and 5th place in terms of national exports. The main product of Russia's forest industry is timber, whose share of the total volume of exported timber is approximately 75–80%. The logging industry is considered to be the basic direction of the whole forest complex. By the end of the 1980s, the USSR ranked second in the world in the export of wood, second only to the United States. As a result of numerous economic changes throughout the past decade, Russia has moved between 6th and 7th place worldwide in this index. For such great information, don't forget to like the video and subscribe to the channel. Thank you. In space, no one can hear you scream, but they may be able to hear a black hole. NASA's Exoplanets Twitter account unveiled audio where listeners can hear what a black hole from 200 million light years away sounds like to the human ear. The space agency also used the tweet to address the widely misunderstood notion that there is no sound among the stars. The misconception that there is no sound in space originates because most space is a vacuum, providing no way for sound waves to travel, they wrote. A galaxy cluster has so much gas that we've picked up actual sound. Here it's amplified and mixed with other data to hear a black hole, they excitedly tweeted alongside a video clip of said hole moaning and groaning. The account is run by a team of scientists investigating exoplanets, or planetary orbs found outside of our solar system. The cluster featured in the video is called Perseus, and the finding was initially released in May in honor of NASA's Black Hole Week. NASA's Chandra X-ray Observatory discovered the data. Astronomers discovered that pressure waves sent out by the black hole caused ripples in the cluster's hot gas that could be translated into a note, one that humans cannot hear some 57 octaves below middle C. They noted about the black hole at the time. Astronaut Nicole Onapu-Mann will join NASA's SpaceX Crew 5 mission as the Dragon spacecraft commander, for which she will be responsible for all stages of flight. It's very exciting, she told Indian Country Today recently about becoming the first indigenous woman to explore the galaxy. I think it's important that we communicate this to our community, so those other native kids, if they thought maybe that this was not a possibility, or to realize that some of those barriers that used to be there are starting to get broken down, she added. Quartz is a chemical compound consisting of 1 part silicon and 2 parts oxygen. It is silicon dioxide, SiO2. It is the most abundant mineral found at Earth's surface, and its unique properties make it one of the most useful natural substances. Quartz is the most abundant and widely distributed mineral found at Earth's surface. It is present and plentiful in all parts of the world. It forms at all temperatures. It is abundant in igneous, metamorphic, and sedimentary rocks. It is highly resistant to both mechanical and chemical weathering. This durability makes it the dominant mineral of mountaintops and the primary constituent of beach, river, and desert sand. Quartz is ubiquitous, plentiful, durable. Mineral deposits are found throughout the world. Quartz is one of the most useful natural materials. Its usefulness can be linked to its physical and chemical properties. It has a hardness of 7 on the Mohs scale, which makes it very durable. It is chemically inert in contact with most substances. It has electrical properties and heat resistance that make it valuable in electronic products. Its luster, color, and diaphaneity make it useful as a gemstone and also in the making of glass. Today, billions of quartz crystals are used to make oscillators for watches, clocks, radios, televisions, electronic games, computers, cell phones, electronic meters, and GPS equipment. A wide variety of uses have also been developed for optical-grade quartz crystals. They are used to make specialized lenses, windows, filters, used in lasers, microscopes, telescopes, electronic sensors, and scientific instruments. The material of beach sand is now the material of the world's most advanced electronic devices.
We live in a world powered by fossil fuels. Coal, oil, and natural gas are the energy sources that fuel our cars, light our homes, and drive our industries. But have you ever stopped to wonder where this energy comes from? The answer lies in the distant past, millions of years ago, when ancient sunlight was captured by plants and microorganisms.
Fossil fuels are, in essence, ancient solar energy stored within the Earth. These fuels represent the stored energy of ancient life, transformed over eons by heat and pressure. Understanding the origins and finite nature of these resources is crucial as we face the challenges of climate change and energy security. We must transition to a future powered by renewable sources if we want to create a sustainable world. The story of fossil fuels begins with the sun, the ultimate source of energy for our planet. Through the remarkable process of photosynthesis, plants and some tiny organisms like algae capture sunlight. They use this energy to convert carbon dioxide and water into sugars. These sugars are their food source, the building blocks of their bodies. When these organisms die, their remains rich in carbon settle in the Earth's crust. Over millions of years, layer upon layer of sediment accumulates, burying the organic matter deeper and deeper. The weight of these layers creates immense pressure, and the Earth's internal heat starts to rise. This combination of pressure and heat sets the stage for the formation of fossil fuels. The type of fossil fuel formed depends on the starting material and the conditions under which it was buried. Coal, the most abundant fossil fuel, forms from ancient forests. These massive trees, ferns, and other plant matter accumulated in swampy environments. Over time, heat and pressure transform this plant matter into coal. Oil and natural gas, on the other hand, typically form from the remains of tiny marine organisms. These organisms, like algae and plankton, die and sink to the ocean floor. They get buried under layers of sediment. Over millions of years, heat and pressure transform this organic material into oil and natural gas. These fuels, lighter than water, often migrate upwards through porous rocks until they become trapped beneath impermeable layers. Fossil fuels are essentially concentrated forms of ancient solar energy. The process of photosynthesis, over millions of years, has concentrated the sun's energy into these convenient and energy-dense fuels. This energy is stored within the chemical bonds of the hydrocarbons that make up coal, oil, and gas. When we burn fossil fuels, we are essentially reversing this ancient process. We break these chemical bonds, releasing the stored energy as heat. This heat is what drives our power plants, powers our vehicles, and heats our homes. It's the driving force behind much of modern civilization. Section 5. The world runs on fossil fuels. The world today runs on fossil fuels. They are the dominant source of energy for electricity generation, transportation, and industry. Coal, the most abundant fossil fuel, is primarily used in power plants to generate electricity. Its combustion heats water, producing steam that spins turbines to generate electrical power. Oil, a versatile fuel, is refined into gasoline, diesel, and jet fuel, powering our cars, trucks, ships, and airplanes. Oil is also the source of many everyday products, including plastics, fertilizers, and pharmaceuticals. Natural gas, the cleanest burning fossil fuel, is used for heating, cooking, and electricity generation. It's also a feedstock for the production of chemicals and fertilizers. Section 6. The depleting reserves of ancient sunshine. While fossil fuels have powered our modern world, their use comes at a cost. We are rapidly depleting these finite resources formed over millions of years at an unsustainable rate. The reserves of coal, oil, and natural gas are not infinite. Extracting and burning these fuels releases greenhouse gases, like carbon dioxide, into the atmosphere. These gases trap heat, contributing to global warming and climate change. We are altering the Earth's climate system, leading to more extreme weather events, rising sea levels, and disruption of ecosystems. Section 7. Embracing the power of now, the renewable energy solution. The finite nature of fossil fuels and their environmental impact underscore the urgent need for a transition to renewable energy sources. Unlike fossil fuels, renewables replenish naturally and have minimal impact on the environment. Solar, wind, hydro, geothermal, and biomass energy offer sustainable alternatives to power our world. Solar energy harnesses the power of the sun directly through photovoltaic cells, converting sunlight into electricity. Wind energy captures the kinetic energy of wind through wind turbines, transforming it into electricity. Hydropower utilizes the flow of water to generate electricity, while geothermal energy taps into the Earth's internal heat. Biomass energy derives from organic matter, like wood or crops. Section 8. a sustainable future powered by the sun. The transition to renewable energy is not just about replacing one energy source with another. It's about creating a sustainable future. It's about reducing our reliance on finite resources, mitigating climate change, and building a cleaner, healthier planet for generations to come. Imagine a world where our cities are powered by the sun, our vehicles run on electricity generated from wind and water, and our industries thrive on clean, sustainable energy. This is the future we must strive for, a future where we live in harmony with our planet, powered by the endless energy of the sun. Section 9. Beyond Fossil Fuels, a Cosmic Perspective. As we stand at this critical juncture in human history, we must remember that we are all interconnected, part of a larger cosmic web. The same star that fueled the formation of fossil fuels billions of years ago still shines upon us today. It offers us a path towards a brighter future, one powered by its inexhaustible energy. Let us choose to embrace the power of the present, harnessing the sun's energy directly and sustainably. Let us create a world where ancient sunlight powers a modern world, a world in balance with nature, a world worthy of the cosmos we inhabit. Across our planet, in places where the Earth's crust is thin, we find a spectacle that reminds us of the immense power hidden beneath our feet. Hot springs and geysers, these steaming, bubbling wonders, are a testament to the Earth's inner heat. They are windows into the heart of our planet, where molten rock and ancient forces shape the very ground we walk on. These geothermal marvels, scattered across the globe, captivate us with their beauty and raw energy. From the depths of Yellowstone National Park to the volcanic landscapes of Iceland, these natural wonders draw visitors from far and wide. People come to witness the spectacle of boiling water erupting skyward, to feel the warmth of mineral-rich waters, and to marvel at the vibrant colors of life that thrive in these extreme environments. But these captivating features are more than just tourist attractions. They are vital parts of our planet's ecosystem, supporting unique life forms and playing a crucial role in the water cycle. They are also a source of renewable energy, offering a glimpse into a future powered by the Earth's own heat. In this exploration, we will delve into the science behind these geothermal marvels. We will uncover the forces that drive them, understand how they form, and explore their significance to our planet and ourselves. Join me as we journey into the heart of these geothermal wonders. To understand hot springs and geysers, we must first journey deep beneath the Earth's surface, where a hidden furnace fuels these spectacular displays. This furnace is geothermal energy, the immense heat trapped within our planet. This heat originates from the very birth of the Earth, billions of years ago. When the Earth formed, it gathered cosmic dust and gas. This process generated tremendous heat, trapped within the Earth's core. Even today, this primordial heat continues to warm our planet from within. But the Earth's internal heat isn't just a relic of its formation. The decay of radioactive elements like uranium and thorium deep within the Earth's crust and mantle constantly generates more heat. This heat, radiating outwards from the Earth's core, encounters groundwater as it seeps through cracks and fissures in the Earth's crust. This interaction between heat and water is what gives rise to the geothermal wonders we see on the surface. In some places, this heated water gently rises to the surface, forming hot springs. Imagine rainwater slowly seeping into the ground, traveling through layers of rock and soil. As it descends, it encounters a zone where the Earth's heat is most intense. Here, the water is warmed, sometimes to temperatures exceeding the boiling point at the surface. This superheated water, lighter than the cooler groundwater above, begins to rise. It finds its way back to the surface through cracks and fissures in the Earth's crust, emerging as hot springs. These springs, often found in volcanic regions, are like natural taps of geothermal energy, continuously pouring out warm, mineral-rich water. The water in hot springs is often saturated with dissolved minerals, picked up during its journey through the Earth's crust. These minerals, like silica, calcium carbonate, and sulfur, give the hot springs their characteristic colors and therapeutic properties. The vibrant hues of yellow, orange, green, and blue often seen in hot springs are not just visually stunning, but are also a testament to the rich mineral content of these waters. Geysers. Those spectacular fountains of boiling water and steam are a more dramatic manifestation of geothermal energy. They are like hot springs with a twist, a plumbing system that creates a periodic eruption of water and steam. Imagine a subterranean chamber filled with groundwater heated by the Earth's warmth. As the water deep within this chamber heats up, it approaches its boiling point. However, the weight of the water above prevents it from boiling readily. Pressure builds within the chamber, like a pressure cooker about to blow its top. Finally, when the pressure exceeds the strength of the surrounding rock and the weight of the water above, the superheated water violently flashes into steam. This explosive expansion propels the water upwards, erupting from the Earth's surface as a geyser. The eruption continues until the pressure is released, and the remaining water in the chamber cools below boiling. The cycle then begins anew, with groundwater seeping back into the chamber, ready to be heated once more. Our Earth is special. It has this wonderful thing called an atmosphere. We breathe it, it protects us from harmful rays, and it keeps our planet warm. But here's the thing. This precious blanket of air is slowly leaking into space. Yes, you heard that right. Every day, about 90 tons of our atmosphere escapes into the vast emptiness. Now, before you start panicking, understand this. It's a very, very slow leak. It's like a tiny hole in a giant balloon. It's going to take billions of years for a serious problem. But it's still fascinating to think about, isn't it? This loss happens because of some interesting physics. Imagine tiny particles of air, full of energy, bouncing around in our atmosphere. Some of these particles, especially the lighter ones like hydrogen and helium, get so much energy that they break free from Earth's gravitational pull. It's like they're launched into space. So yes, our atmosphere is leaking, but it's a slow and steady process. And while it's happening, our planet has some tricks up its sleeve to keep its atmosphere relatively stable. Now let's talk about how our atmosphere actually escapes. There are two main ways this happens: thermal escape and non-thermal escape. Don't worry, these are just fancy terms for some cool processes. Thermal escape, also known as Jeans escape, is all about heat. When particles in the upper atmosphere get heated by the sun, they move faster and faster. Some of them, especially the lighter ones, gain enough speed to escape Earth's gravity, like a rocket breaking free. Then we have non-thermal escape. This is a bit more complex. Imagine the sun constantly throwing out a stream of charged particles called the solar wind. This wind interacts with our atmosphere and can strip away some of it. There are also other factors like chemical reactions and interactions with Earth's magnetic field that can cause particles to escape. It's like a cosmic game of tug-of-war between Earth trying to hold onto its atmosphere and the sun trying to pull it away. And in this game, both sides are constantly scoring points. We can't talk about atmospheric escape without giving a shout out to our friendly neighborhood star, the sun. While it provides us with light and warmth, it also plays a significant role in stripping away our atmosphere. Ironic, isn't it? The sun constantly emits a stream of charged particles called the solar wind. It's like a never-ending breeze blowing through space. When this wind hits Earth's atmosphere, it can transfer energy to the particles, giving them enough oomph to escape. And that's not all. The sun also emits powerful bursts of energy called solar flares and coronal mass ejections. These events are like solar sneezes, sending out huge amounts of radiation and charged particles our way. While our planet's magnetic field protects us from the worst of it, these solar outbursts can still enhance atmospheric escape. So the sun gives and the sun takes away. It's a delicate balance, and understanding this interplay is crucial for understanding the evolution of planetary atmospheres, not just on Earth, but throughout the cosmos. Section 4, maintaining the balance, why Earth's atmosphere stays put. So we've established that Earth's atmosphere is leaking into space thanks in part to our sun. But why isn't our planet a barren wasteland like Mars? Why haven't we run out of air? Well, that's because Earth is a pro at replenishing its atmosphere. Firstly, we have volcanoes to thank. Fiery giants release a cocktail of gases, including carbon dioxide, water vapor, and nitrogen, directly into the atmosphere. Talk about a dramatic entrance. It's like Earth's way of patching up the leaks. Then there's life itself. Plants, through photosynthesis, absorb carbon dioxide and release oxygen, while other organisms contribute to the cycle of gases in various ways. It's a beautiful, intricate dance of life and atmosphere working in harmony. And let's not forget Earth's secret weapon, gravity. our planet's gravitational pull is strong enough to hold on to most of the heavier gases like nitrogen and oxygen, which make up the bulk of our atmosphere. So while the lighter gases might escape, the heavyweights are here to stay, at least for now. Section 5, A Tale of Three Planets, Earth, Mars, and Venus. Now let's step back and compare Earth's atmospheric situation with our planetary neighbors, Mars and Venus. It's like a cosmic case study of what happens when planets lose their atmosphere. Mars, the red planet, is a cautionary tale. It once had a thicker atmosphere, but over billions of years it lost most of it to space. Why? Weaker gravity and the lack of a global magnetic field made it easy for the solar wind to strip it away. Venus, on the case of extremes, it has a super dense atmosphere, much thicker than Earth's. However, it's also incredibly hot and toxic, with a runaway greenhouse effect. Even though Venus loses atmosphere to the solar wind, it's constantly replenished by volcanic activity. Earth, as we've seen, sits somewhere in between. We have a stable atmosphere thanks to a balance of loss and replenishment. We have a strong enough gravitational pull to hold on to most of our atmosphere, and our magnetic field acts as a shield against the solar wind. These three planets highlight the delicate balance of factors that determine the fate of a planet's atmosphere. Studying them helps us understand the conditions necessary for a planet to support life and the long-term evolution of planetary systems. It's a reminder that we're part of a vast and ever-changing cosmos, and our planet's story is still being written. Earthquakes are a powerful reminder that our planet is alive and constantly changing. These tremors, sometimes subtle and sometimes devastating, are caused by the movement of massive tectonic plates beneath the Earth's surface. Imagine these plates as giant puzzle pieces, constantly shifting and grinding against each other. This movement generates immense pressure and energy. When this pressure exceeds the strength of the rocks along the edges of these plates, it is released with a sudden jolt, sending shock waves through the Earth. This release of energy is what we experience as an earthquake. The intensity of these earthquakes varies greatly, from barely perceptible tremors to catastrophic events that can reshape landscapes in an instant. The point where an earthquake originates beneath the Earth's surface is called the hypocenter. The point directly above it on the surface is called the epicenter, and this is where the earthquake's effects are usually felt most strongly. Earthquakes are a global phenomenon occurring along fault lines that crisscross the Earth's crust. These fault lines are like scars on the Earth's surface, marking the boundaries between tectonic plates. Understanding these forces and the movements of the Earth's plates is crucial to comprehending the awe-inspiring power of earthquakes and their role in shaping our planet. Fault lines, those cracks in the Earth's crust, are the battlegrounds where tectonic plates collide and reshape our world. These lines are not static. They are dynamic zones where the immense forces within the Earth manifest as earthquakes. Depending on how these plates move along the fault lines, different types of earthquakes occur, each with its unique impact on the landscape. Normal faults occur when tectonic plates move apart, causing one side to slip downward. Imagine stretching a piece of elastic. Eventually, it would thin and potentially tear. Normal faults work similarly, creating valleys and depressions over time. The East African Rift Valley, a vast scar stretching thousands of kilometers, is a dramatic example of a landscape shaped by normal faults. Reverse faults, also called thrust faults, operate in the opposite way. Here, the tectonic plates collide head-on, forcing one side to rise above the other. This process is what gives birth to majestic mountain ranges. The Himalayas, home to the world's highest peaks, are a testament to the immense power of reverse faults pushing the Earth's crust skyward over millions of years. Strike-slip faults occur when tectonic plates slide horizontally past each other. This grinding motion can cause significant displacement of the land on either side of the fault. The San Andreas Fault in California is a well-known example of a strike-slip fault, notorious for its potential to unleash powerful earthquakes. Understanding the different types of faults and how they interact with the Earth's tectonic plates is crucial to appreciating the dynamic forces that shape our planet, sculpting mountains, carving valleys, and sometimes even creating new islands. Earthquakes are not merely destructive events, they are also architects of change, constantly molding and reshaping the Earth's surface. The way an earthquake alters the landscape depends on a complex interplay of factors.
The type of fault, the magnitude of the earthquake, the depth of the earthquake's origin, and the geological composition of the affected area. Subduction zones, where one tectonic plate dives beneath another, are particularly prone to powerful earthquakes and dramatic landform changes. These zones often give rise to volcanic arcs and deep oceanic trenches. The 2004 Indian Ocean earthquake, one of the most powerful ever recorded, occurred in a subduction zone and triggered a devastating tsunami that ravaged coastlines across the Indian Ocean. Earthquakes along reverse faults can uplift land masses, creating plateaus and mountain ranges. The Tibetan Plateau, often called the roof of the world, is a prime example of the long-term impact of such earthquakes. Over millions of years, repeated earthquakes have thrust this massive landmass upwards, creating a unique and extreme environment. Earthquakes can also cause subsidence, where the ground level sinks. This can occur along normal faults or due to the shaking caused by an earthquake, particularly in areas with loose sediments. The sinking of coastal areas can lead to increased vulnerability to flooding and other hazards. The 1964 Alaska earthquake, the most powerful earthquake ever recorded in North America, caused significant subsidence in some areas, dramatically altering the coastline. The creation of new landforms by earthquakes is not always a slow and gradual process. Sometimes the Earth's crust can rupture dramatically, thrusting new islands above the sea or causing sudden shifts in the landscape. The birth of Surtsey, a volcanic island off the coast of Iceland, is a dramatic example of such a rapid transformation. The island emerged from the sea in 1963 following a series of volcanic eruptions triggered by seismic activity. Earthquakes, those tremors that ripple through our planet, are a testament to the immense forces at play beneath our feet. They are a constant reminder that the Earth is not static, but a dynamic system in perpetual motion. While we often focus on their destructive power, earthquakes also play a crucial role in shaping the Earth's surface and influencing its ecosystems. The uplift caused by earthquakes can create barriers, separating populations of plants and animals and leading to the evolution of new species. The formation of mountain ranges, driven by the collision of tectonic plates, has created some of the most biodiverse regions on Earth. These elevated landscapes provide a wide range of habitats, from lush forests to alpine meadows, each supporting unique assemblages of life. Earthquakes can also trigger landslides, which, while potentially destructive, can also create new habitats. Landslides can dam rivers, forming lakes and wetlands that provide homes to a variety of species. The debris from landslides can enrich soil fertility, promoting the growth of new vegetation. Earthquakes, despite their destructive potential, are an integral part of our planet's natural processes. They are a force of creation and destruction, shaping the Earth's surface, influencing its climate, and driving the evolution of life. As we continue to study and understand earthquakes, we gain a deeper appreciation for the complex and dynamic nature of our planet. From the towering mountains to the deepest ocean trenches, the fingerprints of earthquakes are evident. Recognizing the interconnectedness of Earth's systems helps us prepare for the challenges posed by earthquakes, while also marveling at their role in shaping the world around us. Hello and welcome to the fascinating world of rocks. Today we'll explore the rock cycle. This cycle is like a journey, transforming rocks over millions of years. Rocks are not static, they are always changing. This cycle shows us how rocks are born, transformed, and reborn. The rock cycle is vital to our planet. It shapes our landscapes, creating mountains and valleys. It also provides us with resources like metals and building materials. Without the rock cycle, our Earth would be a very different place. So let's delve deeper into this amazing process. There are three main types of rocks: igneous, sedimentary, and metamorphic. Each type has a unique story to tell. Igneous rocks are born from fire. Deep inside the Earth, it's scorching hot. This heat melts rocks into a thick liquid called magma. When magma cools down, it solidifies into igneous rocks. Sedimentary rocks are like history books. Rocks, sand, or even the remains of plants and animals. These pieces are carried by wind and water, settling down in layers. Over time, these layers are squashed and cemented together, forming sedimentary rocks. Metamorphic rocks are the masters of transformation. They start as either igneous or sedimentary rocks,
But deep underground, heat and pressure work their magic. They don't melt the rock, but transform it. This creates metamorphic rocks with new minerals and textures. Let's follow a rock on its journey through the rock cycle. Imagine a volcano erupting. Molten rock called lava flows out and cools down, forming an igneous rock. Wind and rain slowly break down this igneous rock into smaller pieces. These pieces are carried away by rivers and streams at the bottom of a lake or ocean. Over millions of years, layers of sediment pile up, pressing down on the layers below. The weight and pressure, along with natural cements, transform the sediment into sedimentary rock. Now imagine this sedimentary rock getting buried even deeper. The Earth's internal heat and the pressure of the overlying rocks begin to change its structure. The sedimentary rock transforms into a metamorphic rock, ready to start a new journey through the rock cycle. The rock cycle is incredibly important for our planet. It plays a crucial role in shaping the Earth's surface. The movement of tectonic plates, coupled with the rock cycle, creates mountains, volcanoes, and ocean basins. It constantly renews the Earth's surface, creating a dynamic and ever-changing landscape. The rock cycle also provides us with essential resources. We rely on rocks for building materials, metals, and even energy sources like coal and oil. Understanding the rock cycle helps us locate and manage these valuable resources. The rock cycle is a continuous process, constantly reshaping our planet. It's a reminder that even seemingly permanent things like rocks are in a constant state of change, shaping the world we live in. Every day our Earth gets a special delivery from space. It's not parcels or letters, but something much more fascinating: cosmic dust. Imagine tiny, tiny particles smaller than a grain of sand raining down on us from the vast universe. These little travelers are remnants of comets, asteroids, and even explosions from faraway stars. Now you might wonder, if it's raining dust, why don't we see it or feel it? Well, these dust particles are so incredibly small that they silently float down through the atmosphere. Most of them burn up due to friction as they enter Earth's protective layer. But don't worry, enough of them survive the fiery journey to reach the ground. Scientists estimate that a whopping 100 tons of cosmic dust falls to Earth every single day. That's like having about 55 elephants worth of stardust sprinkled across our planet daily. Now that's a cosmic shower of epic proportions. This constant rain of cosmic dust might seem insignificant because of its size, but don't be fooled. These tiny particles carry within them the secrets of our solar system and beyond. They are like tiny time capsules, holding clues about the formation of our planet and the origins of life itself. So what exactly is cosmic dust, and where does it come from? Think of it as the leftover building blocks from the early solar system. Billions of years ago, when our sun was young and our planets were forming, there was a lot of leftover material floating around. This material, made up of rock, ice, and other elements, clumped together to form comets and asteroids. Comets, often called dirty snowballs, are like cosmic messengers carrying ancient ice and dust. As they travel closer to the sun, they heat up, releasing gas and dust that form their distinctive tails. Some of this dust escapes the comet's gravity and continues its journey through space. Asteroids, on the other hand, are rocky bodies that orbit the sun. Collisions between these asteroids, or even smaller impacts, can create a cloud of dust that spreads out over time. These dust particles, along with remnants of disintegrated comets, become part of the cosmic dance, swirling around our solar system for millions, even billions of years. Now, imagine Earth, our blue planet, making its yearly journey around the sun. As we travel through space, we encounter these streams of cosmic dust left behind by comets and asteroids. It's like walking through a light drizzle, except this drizzle is made of tiny particles from outer space. And just like rain nourishes our gardens, cosmic dust plays a surprising role in enriching our planet. You might be surprised to learn that cosmic dust, despite its size, plays a vital role in supporting life on Earth. It's like a sprinkle of cosmic fertilizer, enriching our oceans and ecosystems in fascinating ways. One of the key ingredients that cosmic dust brings to Earth is iron. Now, iron is essential for all living things, from tiny plants to giant animals. In the vast expanse of our oceans, Microscopic plants called phytoplankton rely on iron to grow and thrive. These phytoplankton are like the superheroes of the ocean, producing most of the oxygen we breathe and forming the base of the marine food web. When cosmic dust settles on the ocean's surface, it releases iron, providing a much-needed nutrient boost for these tiny plants. This, in turn, supports the growth of fish and other marine creatures, ultimately benefiting the entire ocean ecosystem. But the benefits of cosmic dust don't stop at the ocean's edge. When this dust falls on land, it enriches the soil, providing essential minerals like magnesium and calcium, which are crucial for plant growth. So, in a way, we have cosmic dust to thank for the lush forests, fertile fields, and the very food we eat. Cosmic dust isn't just about enriching our planet. It's also a treasure trove of information about our cosmic history. These tiny particles are like time capsules, carrying within them the secrets of the early solar system and the processes that led to the formation of planets, including our own. By studying the composition of cosmic dust, scientists can learn about the different elements present in the early solar system and how they're distributed. It's like piecing together a giant cosmic jigsaw puzzle, with each dust particle holding a vital clue. Furthermore, some cosmic dust particles contain organic molecules, the building blocks of life as we know it. Now, the presence of these organic molecules in space has led scientists to believe that some of the ingredients necessary for life may have been delivered to Earth by cosmic dust. Imagine that. The seeds of life on Earth, potentially sown by stardust. The study of cosmic dust is a fascinating field that continues to unravel the mysteries of our universe. It reminds us that we are all connected to the cosmos, not just by gravity, but by the constant rain of stardust that has shaped our planet and possibly even sparked the flame of life itself.
बिल सेटल कर लेते हैं। रहने दे, मैं Amazon पे यूज नहीं करता। Amazon पे से किसी भी मोबाइल नंबर या यूपीआई पे पैसे भेज सकते हैं और रिवॉर्ड्स तो ओहो आहा हा। स्विच टू Amazon पे करने का स्मार्टर वे।
When we think of mountains, we picture towering peaks. We imagine the Himalayas or the Alps. But did you know that the Earth's longest mountain range is underwater? Hidden beneath the waves is a world of wonder, a place of incredible geological activity. This is the story of the Mid-Atlantic Ridge. The Mid-Atlantic Ridge is not your typical mountain range. It lies deep beneath the Atlantic Ocean, stretching for thousands of kilometers. It is a place of constant change, where the Earth's tectonic plates are pulling apart. This underwater mountain range is a testament to the power of our planet. It is a place of extremes, where life thrives in the darkness. Let us dive into the depths and explore this hidden world. The Mid-Atlantic Ridge is a giant. It stretches for over 65,000 kilometers. That's longer than the Andes, the Rockies, and the Himalayas combined. This massive underwater mountain range divides the Atlantic Ocean in two. It runs from the Arctic Ocean all the way down to the Southern Ocean near Antarctica. The ridge is not just long, it's also very deep. Most of it lies thousands of meters below the surface. We can't see it with our own eyes, but scientists use special equipment to study this underwater world. They've discovered that the Mid-Atlantic Ridge is a place of incredible biodiversity. It's home to unique creatures found nowhere else on Earth. The Mid-Atlantic Ridge is a hidden world, but it plays a vital role in the health of our planet. It's a source of new life and a regulator of our oceans. The Mid-Atlantic Ridge is not static. It's constantly changing and evolving. This is because it sits on a divergent plate boundary. This means that the Earth's tectonic plates are moving apart at this location. As the plates move apart, magma rises up from the Earth's mantle. This magma cools and solidifies, creating new oceanic crust. The process is called seafloor spreading. It's what pushes the continents apart and widens the Atlantic Ocean. The Mid-Atlantic Ridge is a place of intense geological activity. It's home to underwater volcanoes, hydrothermal vents, and frequent earthquakes. These features create a unique and challenging environment for life to thrive in. Despite the harsh conditions, life finds a way on the Mid-Atlantic Ridge. In fact, it thrives here. The hydrothermal vents, which spew out hot mineral-rich water, support a unique ecosystem. These vents are like oases in the deep sea. They provide energy for chemosynthetic bacteria, which form the base of the food chain. These bacteria, in turn, support a whole host of other creatures. Giant tube worms, blind shrimps, and strange bioluminescent fish are just some of the inhabitants of this alien world. These creatures have adapted to survive in the extreme conditions of the deep sea. They are a testament to the resilience and diversity of life on Earth. When we think of deserts, we often picture vast stretches of sand, scorching sun, and unbearable heat. But did you know that deserts can be freezing cold too? That's right, deserts aren't defined by their temperature, but by their lack of rainfall. A desert is any region that receives very little precipitation, typically less than 250 millimeters a year. This means that deserts can be hot like the Sahara or cold like Antarctica, the largest desert on our planet. Deserts are fascinating places with unique characteristics. They experience extreme temperature variations between day and night. Vegetation is sparse, with plants specially adapted to survive with minimal water. These factors contribute to the stark beauty and delicate balance of desert ecosystems. While hot deserts are mostly found around the tropics, cold deserts are found in the polar regions. These polar deserts, like Antarctica and the Arctic, are covered in ice and snow for most of the year, experiencing extremely low temperatures. So the next time you hear the word desert, don't just think of scorching heat. Remember the icy landscapes of Antarctica and the Arctic, showcasing the incredible diversity of our planet's ecosystems. Antarctica, located at the southernmost tip of the Earth, is a continent of extremes. It is the coldest, windiest, and driest place on Earth. Covered in a massive ice sheet, it holds about 70% of the world's freshwater. Despite this abundance of ice, Antarctica receives very little precipitation, making it a true desert. Temperatures in Antarctica can plummet to unbelievably low levels, reaching minus 89.2 degrees Celsius. The continent experiences strong winds, called katabatic winds, that can reach speeds of over 320 kilometers per hour. These harsh conditions make Antarctica one of the most challenging environments on Earth. Moving towards the North Pole, we encounter the Arctic, another example of a cold desert. Unlike Antarctica, the Arctic is not a continent, but a frozen ocean surrounded by land masses. Similar to Antarctica, the Arctic receives very little precipitation, less than 250 millimeters a year, mostly in the form of snow. The Arctic experiences slightly milder temperatures compared to Antarctica, but it can still get extremely cold, with temperatures dropping to minus 40 degrees Celsius or lower in winter. Despite these harsh conditions, the Arctic is teeming with life, showcasing the resilience of nature. Life in cold deserts is a testament to nature's incredible ability to adapt. Plants and animals have evolved unique mechanisms to survive in these extreme environments where temperatures are frigid and water is scarce.